Morning, Doctor. Today we will discuss very nice and important concept, effect of temperature on rate of reaction. Okay, first of all, very careful to understand the concept, the very important thing. Generally, in most of the chemical reactions, what happening, a rate of reaction is directly proportional to temperature. Nothing but T. Means as the temperature is increasing, generally speed of the reaction will be also going on increasing in most of the cases. You know already the rate is also directly proportional to which one? Rate constant. Yes, as the speed of the reaction is increasing, rate constant is also increasing. We studied in the characteristics of K. K is one of the measurements to calculate or to find out the speed of the reaction. Okay, generally in most of the chemical reaction, rate of reaction or speed of the reaction is directly proportional to temperature. We know rate of reaction is directly proportional to rate constant or velocity constant or specific reaction rate. Okay, what is the concept we have to discuss here? You take one of the chemical reaction, reactants are converting into products. For this reaction, I am taking temperature is T. At temperature T, rate constant is denoted by KT. For the same reaction, I am taking another temperature T plus 10 degrees Celsius. This is the very important criteria. Initially, you take one reaction at temperature T, their rate constant is KT. The same reaction, just you are raising 10 degrees Celsius. Then what happening? Rate constant will be also changing. Why? Because rate constant is varies with temperature. Okay, then we are getting rate constant is denoted by T plus 10 degrees Celsius. Can you get the one relation between these, which is a more value? Yes, T is directly proportional to K. Yes, then this is a more temperature. So rate constant at T plus 10 degrees is more than KT value. Now I am telling one more point you have to discuss very carefully. Temperature coefficient. Very important for competitive point of view. Temperature coefficient. What is the meaning of temperature coefficient? Nothing but rate constant at T plus 10 degrees by rate constant at T degrees is always equals to 2 to 3 times. This is what we call as temperature coefficient. I will tell the definition, you see carefully. The ratio of rate constant which is measured at 10 degrees interval is always equals to is minimum up to maximum triple. Are you getting that? The ratio of the rate constant which is measured in 10 degrees interval is always equals to 2 or 2 or 3. Means from this I want to tell one more step you can get it easily. From this I am taking Kt plus 10 degrees is equals to 2 to 3 times of which one? Rate constant at T temperature. Can we make this as a sentence? How? Yes sir, this is a 10 degrees interval. Means what happening? For any reaction, for every 10 degree rise in temperature, 10 degree rise in temperature, what happening? The rate constant value is becoming, what happening? For every 10 degree rise in temperature, rate constant value is becoming minimum double up to maximum triple. Means becoming minimum double and up to maximum triple. Triple means 3, double means its value minimum double. So this is the statement if you are using under calculation. This how it is coming, I will explain later by taking a neat diagram. Don't worry about that one. Just you remember this one. A temperature coefficient is nothing but the ratio of the rate constant which all measured at 10 degrees interval is always equals to 2 to 3. Means what is the indirect meaning? For every 10 degree rise in temperature, the rate constant value is becoming minimum double up to maximum triple. Okay, what is the meaning of this one? Just I will give you one example. You have a chemical reaction, reactants are converting into products. At a 10 degrees Celsius temperature, the rate constant K is equals to 2 ohm. At a 20 degrees Celsius temperature, is there any change in the K value? Definitely why? Rate constant is directly proportional to temperature. So at a 10 degrees, it is becoming 2, but at 20 degrees, how much is asking? From here to here, how much interval amount? 10 degrees Celsius. What is telling? For every 10 degree rise in temperature, rate constant value becoming minimum 2 times up to maximum 3 times. That's why, what is the possibility value here? 4. Up to where? Maximum 6. Yes, he will give an options equals to 2, less than 2, greater than 2, or like that he will give. Then you have to choose either 4 or 6, or in between the value you have to choose. For all chemical reactions, by raising temperature 10 degrees, the rate constant value is becoming minimum value. Minimum means double. It should be double. Maybe more than double up to triple. For example, I will give you one more question. You have a chemical reaction at 40 degrees Celsius, the rate constant value is equals to 5. At 60 degrees Celsius temperature, what is the rate constant value? No question. First of all, from 40 to 50, how much interval is there? 10 degrees interval is there. For every 10 degrees interval, what happens? The rate constant value is becoming double. How much? 10. 50 to 60, how much interval is there? For every 10 degree raise in temperature, the rate constant value is becoming double. Means the rate constant value is becoming minimum 10. Double means 20 up to 30. But definitely it should be becoming double. Just I will give you one more question. For example, at 30 degrees Celsius, the rate constant value for the reaction is 4. At 60 degrees, what is the rate constant value for this equation? Can you get it? That is very good. 30 to 40 degrees first you calculate. Interval is 10 degrees for every 10 degree change. Rate constant value is becoming double H. Again 40 to 50 you have to take it. Again 10 degrees interval. Again it is becoming double. Yes or no? Again 50 to 60 how much interval? 10 degrees interval. Again it is becoming double. Means how much it will become? 30. 2 16s are 30. Are you clear? This is a very important concept that just now I told you for every 10 degree raising temperature, rate constant value is becoming double. I am telling you how it is becoming double up to maximum triple. I am explaining how to understand very carefully the concept. Effect of temperature on K indirectly on rate of reaction I am explaining. Take one of the chemical reaction you have to take on reactants or converting into products. So many nice points is coming, you have to observe very carefully. First of all, I am floating a graph between two variable terms. One is reaction coordinate. Reaction coordinate means where reaction will start, where reaction will be ending. Indirectly it is calling as reaction progress. Reaction progress means where, how it is going on. Okay, on this y-axis I am taking energy of the chemicals I am taking. Okay, you have a chemical reaction, in that reactants will be converting into products. First point, reactants are having basically some energy. Basically, some energy having by them. Whatever basic energy will be having by the reactants is calling as internal energy. Are you agreeing or no? Every body having some energy in them, that is only we are calling as internal energy. Yes, you see carefully. For example, we have reactants, that reactants are having some energy here, nothing but 10 kilocalories energy having by them. Is it basic energy of reactants or no? That's why this energy gap we are showing like which energy? Internal energy. Okay, second point I want to tell, with that 10 kilocalories energy or with that internal energy, reacting molecules are involving in the collisions, nothing but bombardments. In those collisions, what happening? They will not form the products. Why? whatever energy having by them, that is not enough to break the bonds in the reactants. That's why with that energy simply they will do collisions, but no use. That's why what I am telling, the reactants with the internal energy will make the collisions, but will not form the products. Yes or no? That's why those collisions we are calling as ineffective collisions. Ineffective collisions. Are you getting or no? Yes. Then what has to do? They want to break. They want to break means the reactant has to go to some higher energy state. That higher energy state only we are calling as activated state. Are you getting? Yes. What is the activated state? For example, its energy is nothing but 50. Now, what reactant has to be do? The reactant has to go to this activated state. What they have to do? They will absorb some energy. Then only the reactants will be going into higher energy state. That's only we are calling as activated state. Okay, means to reactant how much energy is required to reach activated state? That only we are calling as one more energy. It is nothing but EA. So second point, next point I am telling you, the energy required to reactants to reach which one? To reach activated state. To reach activated state is calling as which one? Activation energy. Activation energy. Activation energy is denoted by EA. So what is the activation energy here? Basically they are having a 10 to reach 50. How much energy is required? 40 is required. That's why activation energy for the reactant in this reaction will be 40. Okay, after absorbing that energy they are going into higher energy state. Then what happening with that higher energy? They are involving in again collisions. Definitely those collisions will be converting reactants into which one? Products. Why? In that activated state, what happening? Reactants are having too much energy. Okay, if molecules are colliding like this, is there any chance for breaking? No. The molecules are colliding like this, then definitely chances will be there to break the reactants and converting into products. That's why I want to write here in activated state. In activated state, whatever collisions is going on, those collisions are perfectly converting the reactants into which one? Products. That's why those collisions only we are calling as effective collisions. Those collisions only we are calling as effective collisions. Okay, right. In the activated state, the reactants having too much energy. This whole energy of the reactants in the activated state we are calling as ET. What is the meaning of that one? Means in activated state, reactants having energy is called threshold energy. Threshold energy. The threshold energy only we are denoting like ET. Yes. What is the meaning of threshold energy? The energy having by reactant in the activated state. This energy is indirectly means what? Internal energy plus activation energy is nothing but whole energy by the reactant in the activated state. Automatically, activated energy is equals to internal energy plus which one? Activation energy. One or two times you ask in competitive examination. What is the relation between threshold energy, internal energy and activation energy? The energy which is possessed by the reactants in the activated state is calling as threshold energy. That is the sum of internal energy plus activation energy. Next, I want to tell one more important information. Delta H. What is the meaning of delta H? Enthalpy change. Thermodynamics. Enthalpy change for reaction. How can you represent or how can you calculate the delta H value for the reaction? Enthalpy of the products minus enthalpy of the reactants. Enthalpy means indirectly energy. So what is the energy of the products is here? Approximately how much? 5. Substitute here, enthalpy of the products is 5 minus enthalpy of the reactants is 10. It is nothing but minus 5. The quantity is not a matter. Sign is very important here. Anyway, here we are getting which value? Negative value. If enthalpy change is negative value, we will call it as which reaction? Which reaction? Very good one. It is nothing but which one? Exothermic reactions. Energy releasing is very clearly did you observe all this? Reactants are converted into products. Initially, reactants were having a 10 kilocalories energy, but products are having a 5 kilocalories energy. Means what happening? Energy loss is happening. Energy loss means what? Releasing. Energy releasing is calling as. No, for example, in some other chemical reaction, delta H may getting a positive. Then what we can tell the chemical reaction is a which reaction? Endothermic reaction. This is one of the important concepts to understand the temperature, but still we didn't discuss that point. Basics we are learning. So, in any chemical reaction, in every chemical reaction, reactants are having some basic energy. The basic energy is called as internal energy. With that internal energy, they are involving in the collisions, but they are useless. That's why they are calling as ineffective collisions, because they won't give the products. Then they have to go to higher energy state. Higher energy state only we are calling as activated state. Okay, here activated state energy is how much? 50. But from 10 to 50 to reach how much energy is required? 40 is required. That's only we are calling as activation energy. Very carefully have to see. The energy which is required to reactant to reach activated state is calling as activation energy. After reaching activated state, the reacting molecules are having too much energy. With that higher energy, they are involving in the very perfect collisions. Then they will break down and converting into products. That's why those collisions only we are calling as effective collisions, which are happening in the activated state. Okay, but here we have to discuss one more thing. In the activated state, the reacting molecule having energy is nothing but whole energy. Whole energy means nothing but internal energy plus activation energy. Together we are calling as threshold energy. Are you getting? Basic energy is calling as internal energy. Energy required to reactant to reach activated state is calling as activation energy. In the activated state, reactant molecule having whole energy is calling as threshold energy. Threshold energy means nothing but internal energy plus activation energy. Are you getting? Yes. Later we have to discuss for chemical reaction compared with reactant with products are having less energy. Less energy means energy losing. Energy losing means exothermic should be coming negative value. No, if products are coming here, compared with reactant, products are having 30 means more energy. How? By absorbing energy. By absorbing energy means they are calling as endothermic. All of you clear? Yes. You have to remember very carefully those all terms. Okay. Based on the basic points, now we are perfectly explaining the effect of temperature on rate constant. You have to observe very carefully. In a chemical reaction, we have reactants. Reactant means only one reactant is there? No, so many are there. All those reacting particles will have the same velocity. No, that is only nothing but kinetic molecular theory. In the first year, we learn under states of matter. Means in the chemical reaction, all reactant particles will not have same velocity. Same velocity is similar to which one? Kinetic energy, because of in this way. Means whatever chemical reaction you can take, there so many reacting particles will be there. All reactant will not having same velocity as well as same kinetic energy. Means in the reacting mixture, reacting particles are having different velocities. Means different kinetic energies. Now I will tell one point here. At a particular temperature, fraction of reactant molecules having a particular kinetic energy, particular velocity, or we have to work out kinetic energy. Particular velocity or kinetic energy is constant. constant or remains same. What is the meaning of this one? At particular temperature, fraction of reactant molecule having kinetic energy remains constant. Did you remember KMT, kinetic molecular theory of gases, last point? So average kinetic energy is directly proportional to absolute temperature. You are maintaining same temperature, then average kinetic energy should be maintaining constant. If you are doing disturbing the temperature, definitely kinetic energy will be changing. What I am telling you, at a particular temperature, a fraction of reacting molecule having particular kinetic energy, whatever it is, but it should be maintained constant. Why? You are maintaining temperature is constant. Okay, I am telling one more point here. What is the meaning of fraction of molecules? Fraction of reactants. Yes, here you got for one word. Anybody? What is the meaning of fraction of molecule? It is nothing but small n by capital N. For example, you taken 100 molecules. Out of 100 molecules, 90 molecules are having one particular kinetic energy. The ratio is calling as fraction of that number of molecules. Means, yes, small n. Small n means is nothing but number of reactants, that particular kinetic energy having molecules by total number of reactants. Total number of reactant. This ratio only we are calling as fraction of molecule. Fraction of molecules of this one is nothing but 90 by 100. 0.9. 0.9 is the fraction of that reacting molecules are having a particular kinetic energy. Fraction of molecule is defined as the ratio of number of reacting molecules which are having that particular information by total number of reacting molecules in the reaction. So, all of you get it? Okay. Now, I am telling very important information to see carefully. I am taking graph. On this graph, I am taking here kinetic energy of gas particle. I am taking. Here, I am taking fraction of molecules. I am taking fraction of reactants or reactant molecules. I am taking. Denoted by small n by capital N. Particular molecules by all molecules. Okay, if you take this chemical reaction, not only this one, you can take any chemical reaction, generally we are getting graph like this. Observe very carefully like this. This is the information you studied at a particular temperature T. What is this one? Yes, here kinetic energy is, for example, 10. 10 kilocalories kinetic energy having by some particular number of molecules. Like that will be going on. This is the maximum number of molecules that are having a particular kinetic energy that is specially calling as, anybody? Most probable kinetic energy. Most probable kinetic energy. Do you remember in the first year we learned three types of velocities: RMS velocity, average velocity, most probable velocity. CT, C bar, C. Okay, this is nothing but the most probable kinetic energy. What does it mean? In that molecule, maximum number of molecules are having this kinetic energy, that is only calling as most probability of that kinetic energy having by maximum number of molecules, that only calling as most probable kinetic energy. That is what is important for you. And what is this area? For example, I am shading this area. You have to observe very carefully. A, B, C, and this is D. Okay, you shade this area. What information is given by this area? Anybody? This area will give the information regarding that. For example, 10 molecules is there. What is the meaning of this one? What is the meaning of this one? A, B, C, D at a temperature T. A, B, C, D area. A, B, C, D area will give the information to us regarding fraction of molecules which are having more kinetic energy. Means ABCD area will give the information regarding fraction of molecules which are having their kinetic energy is greater than or equals to activation energy. Means those fraction of molecules are having too much kinetic energy. Too much kinetic energy means definitely they are going into activated state. Definitely they are participating in the effective collisions. Definitely they are converting in the products. Means ABCD area at temperature T will gives information regarding fraction of molecules which are having their kinetic energy is greater than or equals to activation energy. Means they are having too much kinetic energy. No? Definitely they are overcome or they are going into activity state. Definitely they are converting into products. Now we are discussing about another graph. How much variation have we maintained? 10 degrees variation. That is nothing but T plus 10 degrees. Okay, some little bit changes is coming in the graph like this. Like this will be coming. This is the graph related to T plus 10 degrees variation. That's all you have to study now. Okay, we have to take this area, same one information will be there, and later we have to take this area will give us information already ABCD over no EF will be there. Okay, to show the variation, I'm drawing like this. Another cross lines I'm drawing here. See carefully, like this. Yes. At T plus 10 degrees Celsius, what is the area? A, B, E, F. A, B, E, F area will be there. It indicates A, B, E, F area indicates fraction of molecules which are having kinetic energy will be very high, it should be more than activation energy. It is around 20. Are you agreeing or no? Definitely. So means ABEF area is gives the information regarding which one? Fraction of reactants which are having their kinetic energy is greater than or equals to activation energy. Yes, from this only we can tell information. At that T temperature, how many molecules are having more kinetic energy? 10 molecules. But by raising